Okay, so alright, so we have another question, another suitable question. So these questions used to come out very well in Jamb, okay? Most especially the objective aspect. Alright. So imagine you see questions like this. It said two bodies X and Y of masses 5.0 kg and 7.5 kg respectively are connected by a light inextensible string as illustrated in the diagram below. If X is placed on a rough surface of coefficient of friction is 0.5, calculate the magnitude of the Roman figure 1 normal reaction on X and Roman figure 2 frictional force between X and the surface, then Roman figure 3 tension in the strings. Okay, but I want to add to your knowledge, what do you understand by inextensible string? So most times you always see this kind of thing in a question. Inextensible strings are strings in which their lengths are very constant, in the sense that you don't have a new length. You don't, in cases whereby you used to have extension, nothing like that persists in it. They are just the kind of string that are fixed. They cannot stretch, they cannot extend, so they just have a natural length. Okay, so that's an inextensible string. All right, back to this question. Two bodies, these are the two bodies, this and this. Then another thing I want you to know is that a friction is going on here and while suspension is going on here. Okay, because this one is suspending, hanging. There's an hanging force here for body. This one is resting, so a friction should be on that. This one is pulling this one. You can see the mass here is greater than this, so obviously this will be pulling this. So as a result of this pulling this, the friction is going to be what's taking place here. Alright, the dragging will be creating a mindset of friction. That's it. Alright, so back to this question. They said we should what? Calculate the magnitude of normal reaction on X. Now we are dealing with X. What's our normal reaction on X? Alright, so let's solve number one. The normal reaction on X, the normal reaction on X. So remember that normal reaction on a plane surface, when we were talking about friction, is equals to what? It's also equals to weight force. On a plane surface, normal reaction is equals to what? Weight force. But when you are talking about inclined plane, it's a different case entirely. If it were to be inclined plane, it's going to be R equals to W cos theta. That one's empty. Do you understand? So, but because we are talking about a plane surface, but this one is out of it. No stress. Show you again, no issues. So now, don't forget also that our weight force is what? But our weight force is equals to what? Mg. If it was to be force is equals to what? Ma. Are you getting the point? No issues. So then we say that this R equals to weight force equals to what? Mg, which implies that our R is equals to what? Mg. So don't forget, we are looking for what? Our normal reaction on X. So our normal reaction on X to be R equals to Mg, then where our M on X is what? Because we are talking about X is 5.0 kg. Then our G is constant to be 10 meters per second squared. Take note of that. Alright, so we now have that what? Then our R is equals to what? Is 5.0 multiplied by 10. Then that gives us what? That gives us 50 Newton. So that is our normal reaction of S. No issues. So Roman figure 2, let's solve the problem. Roman figure 2. Alright, for normal figure 2, frictional force between X and the surface. So we want to calculate our what? Frictional force between X and the surface. What's our frictional force? Now, frictional force between X and the surface. Now you know that, recall that mu is equals to frictional force over what? Normal reaction. Okay, so our mu is equals to frictional force over normal reaction. So from this place it implies that our frictional force is equals to mu what? Mu R. No stress. No, this means that our coefficient of friction multiplied by what? The reacting force. Alright, we are getting there. So the answer is your what? Normal reaction. Okay, so now our F is equals to what? Mu then R, which is equals to what's our normal reaction? They stated it in the question. They said our coefficient of friction is 0.5. So we're having what? The 0.5 multiplied by what we got for this from initial, that's 50. Okay? So when you multiply this one, then you're having what? Our frictional force to be 25 Newton. No stress. 25 Newton. No stress. Let's go there. I do have time. Physics is a bastard. Alright guys. Oh. Alright, now I said the tension in the string. The tension in the string. Let's go there. What type of string is it? Inextensible. Alright, cool. Now, another thing I want to let you know is that, you see, whenever you have a string like this, like you have a kind of picture like this, I've told you earlier on that a friction is occurring here, y and what, and suspension is occurring here. So which means that at this junction here, the tension that will be here will be much more greater than the frictional force. Are you getting me? The tension here will be greater than the frictional force. In what sense? It suffixes that at this side, at x, at point what? At point x, our expression for the equation here is going to be T minus F is equal to MA, because the tension is greater than the force. So the tension, you are going to be subtracting the frictional force from the what? From the tension force, because the frictional force is occurring here. Okay? Are we making any sense? That's it. So now at this junction, we're having that T minus, the expression for this one is what? Mu R, okay, equals to MA. Alright? So that's our T minus, this one is, they give us mu to be 0.5. So it's 0.5 multiplied by 50 is equals to our mass for x side at point x. Our mass is 5.0. Don't forget 5.0 kg. So we're having what? 5 times A, that is this. And we're having what? T minus what? 25 equals to 5A. This is equation 1. Alright. At point what? Y. At point Y, F is greater than T. What did I say? At point Y, F is greater than what? Than T. So at this junction, if F is greater than T equals to MA, so it means that this one is going to be F minus T equals to MA. Okay, then if you rearrange it, that will be minus T plus what? F equals to MA. So which means that this place is going to be minus T plus F is equals to MA, because F is greater than T here. So the tension is going to be negative. Alright, so which means that there's no friction occurring here. I hope you know that. No friction is occurring here. So in the sense that at this junction we are going to be having minus T plus, alright, so what's going to be, this is going to be 7.5. So 7.5 multiplied by 10. Alright, 7.5 multiplied by 10. So that will be equals to 7.5A. So this is going to be minus T plus what? 75 equals to 7.5A. Alright, so we are going to solve this simultaneously. So this equation what? Equation 2. So I'm going to solve equation 1 and 2 simultaneously. That will be what? That will be equation 1 plus equation 2. That's the only way we can solve that. So that will be T minus what? 25 equals to 5A, then minus T plus 75 equals to 7.5A. This 1, this 2. Let's see how we can resolve this here. So when we say this plus this is gone. So we have minus 25 plus 75 is equals to 5A plus 7.5A. So let's get our calculator ready. Alright, so this one is 80. This one is, no, when we remove this from this, we're having 45, if I'm correct, is equals to 12.5A. Okay, let's check. Minus 70 minus 25 plus 75, that's 50. Oh, sorry, this is 50. This is 50 and this is 12.5a. Then our a is equals to 50 divided by 12.5. Then a equals to 50 divided by 12.5. A equals to what? 4.0 meter per second square. So what are we asked to calculate? So they say we should find the what? They say we calculate the tension in the string. So since you've been able to find the tension in this string, so we can just substitute for A in any of the equation. Okay, so you now come here, you see substitute for A in equation. Let's pick equation 1. What's equation 1? T minus 25 equals to 5a, which implies that t minus 25 equals to 5 into 4. Okay, then t minus 25 equals to 20. Alright, so that's t is equals to 45 Newton. So the tension in the string is thereby 45 Newton. So no stress. So this is the question you should be expecting in your Jamb 2026. So you can look for more questions that are similar to this, so you can begin to practice. Practice make perfect. If you practice, you will definitely understand this. If you don't get this, go back to this video. Go get over and over again. I remember I'm also very like tutor. So if you want to book a section for your online class, so you can kindly look for my number around this video, text me from wherever country you are watching from. And we have a physical class for those of you living around Ibadan, Akwete, Awotan, or living around Funab campus, from Camp to Funab, Accord, and the likes. So you can DM. Alright. So love you all. Love you guys.